Hello, everybody. Good evening.
Good evening, sir.
How are you all? All fine? So, all are here. Pradeep, Vivek, Deji, Sairati, Sudipji, Sumant, all fine. So, did you go through last lecture, Profibus and Profinet? Everybody? Okay, thank you.
Yes, sir.
Exactly. See, communication protocols are so much vast and so much different variants are there. There are many, lots of things are there in communication protocols. If you are really want to understand it deeply, and frankly speaking, I am also going through all those protocols right now, because it is not required in our field while we are doing something, because everything has been set already and we just use those protocols, isn't it? We simply follow the guidelines from the OEM, and simply what we do is we purchase those converters or the links or the cables and simply connect it. Okay, so if I am having a PLC or a controller, and if I need to connect it with another PLC or something, then simply I have to go whether there what type of means facilities are available on that particular controller, whether it is having some Modbus switch or your Profibus connector or something, and then we simply compare, we check the compatibility, and we can purchase the cables, we can purchase the connectors, and simply connect it, and then we do our things. Okay. Now, if you are interested to means, understand all the differences from in a deep manner, then you must have idea regarding those OSI models and all, how the packets are made, how we are addressing each and everything and all those things. And for a operation engineer or maintenance engineer, it is not that much required. But still, I am trying to make everything very simple once again for regarding your Modbus, and all kind of varieties of cables are available, what are the differences and all that. But it is taking time, as I really get lesser time to go through all those things in there. So today,
I have a question. May I ask, please?
yeah, sure.
Yeah, what I wanted to ask is, there are various installations in various sites,
Yeah.
depending on the manufacturer's brand or the manufacturer's model that is being used. Some of them earlier used to have a Profibus communication. Some used to have Modbus, majorly.
Mm,
Profibus being with a protocol of Siemens, Modbus being that of Schneider. And
mm,
these days, almost all companies are upgraded to Ethernet. So, like today, if I have to go and find that this is purely from maybe from marketing or sales point of view, that if
mm.
I have an X install base and I have a Y brand with me and the protocols differ, in that case, what is the best way to uh, approach the situation? Or is it true that it's like ideally, since today Ethernet is a very acceptable communication, so it's like everything should boil down to Ethernet.
No,
I just wanted
exactly.
to understand.
Exactly. See, Ethernet is a wide acceptable thing, and it is easy to make communication in between. Means heterogeneous controllers, is not it? Uh, if if the controllers are really having Ethernet communication, then it is well and good. This becomes very easy to configure in between these things. Now, it is not mandatory that you should go for Ethernet only, because even RS-232 can make you work. RS-232, but the limitation is what? The limitation is the length of the cable. Means how far your controller and your slave device to be connected, or your instruments
Correct.
are where are your instruments connected? How many instruments are connected?
Hmm.
Mainly it depends on the number of IOs and the area, vast area.
Correct.
Two things: the number of IOs we are going to handle, and the area mainly. Now, suppose the area is large, and
Hmm.
your instruments are scattered in all the fields, and you are using, say, more than two or three or different controllers to control them, and they are wide apart. Then it is better, as we have seen, that it is better if you are using your Profibus or Profinet. Then it gives you the means if it gives you the advantage that you can segregate, or you can uh, control your cost from wiring point of view. So this gives added advantage. Number two, the means interference of high voltage over these low voltage signal, that is our instrument signals, that
Hmm.
these are very low voltage and low current signals. So the interference of the high voltage lines or power lines will be can be somehow we can control it if we are using some Profibus cable, because the Profibus cable is giving you transmitting the data digitally. Okay, and if you are using those directly, if you are transmitting those 4 to 20 milliamperes or say voltage, DC voltage signals or cables, then what will happen? There are chances of interference and some kind of problem. Now, as your question that whether you have to go well everything in Ethernet or not. So my suggestion would be no. Ethernet is not the only solution. Okay. So you have to go through the situation, that how many devices, whether you are connecting for multi-drop situation, even in the multi-drop situation, that the number of controllers, how many number of controllers you are going to interconnect. If there are only one controller, then why to go for Ethernet also? You can use simple RS-232. If the length is in between your, how many, I think it is 50 feet or so. Okay. And rest depends on what type of controller already the plant has installed. They are having already which kind of controllers are there, because once they have installed something, and if you are trying to obsolete it, or if you are trying to modify the present control system,
Mm.
you have to identify that exactly the what are the specifications of the present controller, what are the facilities available, and if it is having those facilities, you can communicate with other controllers.
Okay.
And the
Sir,
details of
I have
that,
one question.
yeah.
Sir, like a network, we are using like a peer-to-peer network and client server client network. Okay, and a star, like a star topology and bus topology, like this we are using for some condition. There is any suitable condition for this protocol? We can use that.
Uh, See, there are some restrictions based on the protocols. Okay, likewise, if you are using Modbus, uh, then you cannot go for star topology. The Modbus should be connected in daisy chain manner. So there are restrictions based on the protocols. Otherwise, you can connect if the protocols allow you.
It
So,
means if we if we are using like a star topology, then we have to use Profibus. And then if you are using like a simple networks, then we can use the Modbus. You are telling like this.
it depends on your controller, which already, if you have already selected your controller, then there is no other option. If you are on the point that okay, you have to decide that which controller to be selected, that whether you want Modbus or you want Profibus communication or not. Okay, now then you can decide on those things. If you are already having some controller, then you have to definitely go with the availability of the communication facilities.
No, why I'm asking this question, because in my company,
Hmm.
before earlier we are using a Modbus.
Hmm.
Okay. Then after that, they are plan to apply the Profibus. There are two brands there, Honeywell and Siemens.
Hmm.
Siemens supports the Profibus, and earlier version they use the Modbus protocol. That is the why, which situation we have to choose which protocol we have to use for that.
It depends on the people like our Sudip ji, how they can make you understand that your current topology is not that good, and you are facing problem, and how can the efficiency can be increased by changing your Modbus with your Profibus also. Otherwise, I don't think that there is something, because if you are using Modbus and you are using Profibus, it remains all same until and unless you are having a big area to be covered and number of IOs, and if you are trying to decentralize it in those factors, based on those factors. If the connection remains same, if your means I have seen in some plants that okay, all the controllers and all the IOs, all the modules are in the control room, and we are laying out all the cables and from field to control room, and then if somebody is saying that okay, no, Modbus is it is better to go for Profibus, there is no difference at all. There is
Even
no
I
difference.
have seen, sir, that different sections have different communications. In we do have 2 to 3 sections, okay, in which presently I am working. So one section is having a Modbus, one is having what it's a Ethernet, one that. and and one is having that old Profinet one. Okay. Sorry, device net. That device net one.
So that depends on which controller you are using.
All are using, mostly they are using Allen Bradley one something, Allen Bradley controller.
So device net is mainly for your Allen Bradley only, and Profibus is for Siemens. Okay. So if say you are connecting your device net with your Profibus, and if there are something like you have to convert the data compatible, then you have to check that okay, Ethernet means you can collect everything.
Order.
One order.
Syed Ali, maybe.
So means you have to.
I'm not. I'm just listening.
So you have to bring everything on a centralized switch, which can convert those everything in a compatible manner. And from all brands, if you see the compatibility, then Ethernet is the best option. Okay, so you can convert everything you can bring everything to your Ethernet switch, and then you can connect it to all other devices.
Which is called ETAP switch even. I know.
Yes. Switch, Ethernet switch. Now there are lots of converters are available. You can use those converters to convert these data from one mode to another. But there are some restrictions, like suppose you are using Modbus RTU protocol, and in other you are using Modbus ASCII. Both are Modbus, but they will not communicate with each other. They are two different protocols. Modbus ASCII is not compatible with your Modbus RTU. Okay, so I told you that there are so many things, and they are really the addressing systems and all, lots of things are there, and I am trying to concise those things so that easily you can understand. Likewise, I have given you the Profibus and Profinet thing. Now I hope this part is clear. Profibus is totally clear to you. Profibus TP, Profibus PA or Profinet. This part is clear. Is that it? Now I am working on your Modbus things like Modbus RT, Modbus ASCII, and Modbus class, everything. And I will be giving you a device net, control net, the details in detail, when to be used, what are the differences between them. I'll be giving you, but in my next lecture. Okay. Anything else? Pintu, क्या हाल है?
ठीक है सर, अभी पुणे आया मैं 2 दिन पहले, आज वैक्सीनेशन भी करवाया मैंने, इस वजह से थोड़ा।
वैक्सीनेशन करवाया?
हाँ, कंपनी की फैसिलिटी थी वैक्सीनेशन करवाने की, इस वजह से हो गया जल्दी।
बढ़िया, ध्यान रखो। I have heard that after vaccination the immunity goes very low for a few days.
No. So it's fine. It depends on the person to person. Look, on 6th of May, being a perk of working in Godrej, on 6th of May, from 1st of May, the government allotted vaccination for 18 plus. But on 6th of May, I took my second dose. So, seeing that depends person to person. Some get fever for 3 days, some get fever for 1 day, some don't even get fever, some feel body pain. Okay, that depends. I suggest go for an antibody test before you take a vaccine, so that you will get clear picture that you need right now, what is the condition of your body, you should go for vaccination or not.
Good suggestion.
Pradeep, did you check मैग्नेट लगा के चेक किया है क्या?
नहीं नहीं नहीं, मेरे साथ ऐसा कुछ भी नहीं हो रहा है, मैंने सब
अभी बहुत वीडियो वायरल हो गया, मैग्नेट चपक रहा है जहाँ पर इंजेक्शन दे रहे हैं वहां पर।
नहीं, ऐसा कुछ नहीं हो रहा है। अगर ऐसा होता तो मेरे को प्लांट में से
And
जाने भी नहीं देते।
and that too stainless steel spoon and all, no?
हाँ सर, यस, हाँ हाँ, नॉट इवन आयरन, एसएस।
SS material is sticking up my magnetic fields. That's a nice one. So, what to do today? We have done so many things, no?
Sir, have you already completed the session on drives?
VFD?
Huh?
No.
No, I think so. No.
Not done. VFD is not done. So I think we have done so many things. If you have really gone through those things and if you are remembered, not it. We have done your DCS system and SCADA system, etc. So, yeah. Okay, let us take the section 5 and today. Okay, I'm working on this. I need one more class to cover this. On my next lecture, I hope I will be can complete this section 4. So section 5 is your PID control valve, power cylinder, calibration fault finding. Let's talk on this, on the field devices that we use. Isn't it? So, we all know regarding the field devices like your SOV. What is SOV? It is your solenoid valve. Is that it? So we all are familiar with this particular thing, solenoid valve. And what is solenoid? Solenoid is nothing but a coil, and solenoid valve is using this coil if you are controlling some kind of valve or no. Now, can you tell me if I want to control a solenoid valve, what kind of connection I have to make with the PLC? If I want to control a solenoid valve, what signal I need to control this?
Digital signal.
Digital signals.
Digital what? Input or output?
Output.
Yes. So I have to connect the solenoid valve with some digital output channel. Okay. Now, this solenoid valve may be your 24 volt DC or your 220 volt or 110 volt DC or something. Isn't that it? So this depends completely on the supply required for this coil. Now, if I am connecting it with a PLC or so, and if I am connecting with through some digital output card. So this is my digital output card. I have to ensure that, okay, whether my card is supplying 24 volt DC or it requires some external power source. First, I have to identify that. Whatever type of PLC, I always stop on generalized PLC. Means I don't know what type of controller you are using. Now, what is my way of working? Suppose I am having a controller and I have to connect a solenoid bulb with that controller. So first I have to identify the slot or the channel, which in which channel I have to connect this bulb. Now, what is next? I have to check whether this channel is having 24 volt supply from internal source or not. If it is not so, then what I have to do? I have to connect it from a 24 volt source from outside. And if then what I have to consider? I have to consider the coil voltage. If the coil voltage is also 24 volt, then I can make it directly. If it is not so, then what I can do? I have to use some relay card or a relay, 24 volt relay. Then the digital output can be directly connected to the relay. And from the potential free contact of this relay, what I can do? I can connect my solenoid bulb. So this is the simple connection for solenoid bulb that will work for you. And since it is simple digital output channel you are using, so in your logic you have to identify the address of this channel. Not it. You have to identify the address of this channel and you have to configure it accordingly. So whatever channel you are using, whatever number or which number of channel you are using, you have to trigger that particular channel based on the condition what you want for that your solenoid should be on or off. So this is very simple. When you are considering a solenoid bulb, it is simply a on-off device. So if your channel is on or off, then your work is done. And regarding the programming part, we know we can use your ladder logic or functional block diagram, and we can trigger that particular channel. That part is already done. Now, suppose it is not solenoid valve, but it is a power cylinder. Do you know what power cylinder is? Power cylinders are some kind of cylinders.
Used for pneumatic operations.
Yes. So suppose this is a cylinder for on-off purpose or for regulating purpose also. So if this is a cylinder, where we use these power cylinders, we can use to open some dampers, or for even for your hydraulic operations, you can use these power cylinders. Okay. Power cylinders comes in two varieties. One is called simple power cylinder or on-off power cylinder, or other variant is called your RPC. RPC means your regulating power cylinder. Regulating power cylinder. So regulating power cylinder means you can control the position of the piston. Likewise, if you want 10% opening, you can control it. If you give a command 25, 35, 5%, so you can control in between. But if it is a simple power cylinder, that is again a on-off device. It will be on or it will be off. So suppose we are considering a pneumatic power cylinder. The power cylinder can be pneumatic or hydraulic. For example, if you have not seen a power cylinder yet, then suppose we all have seen JCB. Now, the JCB bucket you have seen, the crank and things. So how it is operating? There are hydraulic power cylinders. There are hydraulic power cylinders that have been connected, and those cylinders are moving up and down, and the bucket is going up and down, and so. So there may be hydraulic, or this may be pneumatic. Now in our industry, we use in general pneumatic power cylinder. Power cylinder has two connections. One is here at the end and at the starting. Now if air is going inside from this port, then what will happen? This will push the piston, and your lever will be coming out, and your, suppose I have connected one dumper over here, so dumper will open or close. Now when I have to close the dumper, then I have to give supply from this end. Okay, that means I have to give supply either from port 1, suppose this is my port 1 and this is my port 2. So either I have to give air supply from port 1 or port 2. And there is a piston, which will be moving in and out. Now what I have to do, I have to identify the position of this piston. I have to identify this position of the piston, based on which all the logics will be made in our PLC. Because if you do not know, suppose you have given a command, okay, or suppose it is a delivery dumper of any fan, industrial fan or something, and you have given command that okay, on. Now whether it is on or off, how you will be knowing that? So there are two parts. One is command part. You have to give some command to open or close this power cylinder, and another part is the feedback part. You need some feedback from field so that you can know the exact position of this piston. Now how we do it? There are two switches we can connect, and these switches are called your reed switch. Reed switch. Okay. How this reed switch work?
Sir, sorry, just 1 minute. So this concept of switch or this feedback, this comes with on-off switch also, like on-off valves also. This feedback one,
Reed switch.
not reed switch, but this feedback one. That whether it's if
Yes, exactly. Exactly. If you are using any kind of field devices, and if you want to know the position whether it is on or off, you need some feedback from the
same.
field.
Okay.
Now reed switch are specifically used for your power cylinder. Okay. So how this reed switch works? Reed switch works magnetically. Okay. These are some kind of magnetic switch, and if you open this power cylinder and if you open this piston even, then you will get that there are two magnets inside this piston. There will be magnet. Now if this magnet is coming here, then this switch will become on, and if the magnet is coming here, then this switch will be on. Okay. Now based on the position of the piston, you can get signal from this reed switch to your PLC or your DCs. Okay. So these will be connected to your digital input card, and how to give command to this power cylinder. Since it is a pneumatic cylinder, I already mentioned once that our controller is giving signal which is electrical signal, isn't it? This is a electrical signal. Now controller is giving electrical signal, and we need pneumatic supply for this instrument or equipment. So I definitely need some kind of converter over here, isn't it? So I need some converter which can convert this electrical signal into pneumatic signal. Can you tell me which type of device can be used to control this power cylinder?
Positioner 3 to 15 psi, 4 to 20. Sorry, near about like that psi.
Why Why you need to use this positioner over here?
Because for no, I know I am wrong. For the controller, we use this positioners to convert 4 to 20 to 3 to 15 psi. But now I just after
But
saying that I
yeah,
remember that it is a digital one.
this is a digital, exactly. So since it is digital, that means you need on-off converter. And what can be used? Anybody, any suggestion?
Some switch.
What type of switch? I need a converter which can convert my electrical signal into pneumatic signal, and I need only on and off.
DAC use, we can use DAC.
No. What is? It is.
Digital to analog convert, sir.
Why you need a analog converter? Yes, Vivek is right. We can simply use a SOV over here. Is that it?
Sorry?
We can use an SOV, solenoid valve. We can use a solenoid valve. If it is a solenoid valve, then what will happen? You need on-off. Is that power secondary? You are giving some command on command. Then say 24 volt is coming over here, and this solenoid valve will act, and this will allow your gear to pass through this port. On the other hand, if the 24 volt is not here, then this port will act, and this port will be connected to this. So air will be going through this port. So it is simply a double acting solenoid valve can solve your purpose.
After this, can we have some detailed conversation about types of SOVs? Because this thing like this directly, I'm just a bit confused. Just
Okay, there is nothing like that. Solenoid valves comes it can be a single acting or double acting solenoid valves. So single acting means what? If you are giving supply to the coil, then there will be a single port through which the air will be supplied. Okay. So a solenoid valve, suppose this is my solenoid valve, it will be having two ports. One port will be used to give air supply to it, air supply at whatever pressure you want. So you can use a air filter regulator before that to control regulate the pressure, and this air will not be passed through your output port. This will be my output port until and unless this solenoid is acted. So there will be a solenoid, and the power supply, based on the power supply of the solenoid, you have to give it the supply. There are various different types of solenoid are available. Now, if suppose it is a 20, in general, in instrument purpose, we use 24 volt DC solenoid. So if it is 24 volt DC, your PLC will supply a 24 volt over here. And if 24 volt is coming to this coil, it will generate a magnetic field. This magnetic field will pull or push this particular plunger or a ball will be there inside that. This is definitely a solid state design, solid design. So inside that there will be, if you open the solenoid valve, you will get some kind of small ball or some small plunger. So it will attract it, or it will attract it downward or upward or sideways. So accordingly, the port will be open. Okay, there will be a lever. So this will move inside that, and this port will open. So your supply air will be coming to this port, and it is going wherever it is required. Now, when we are talking about our double acting solenoid valve will be having 3 ports. So one will be your supply, You are connecting your supply here, and two ports will be one will be your output one will be your output two. If the supply is available, then suppose your output one is open, and if supply is not available, then your output, oh sorry, this not this supply, but supply to your solenoid. If supply is available, then suppose your output one is open, and if supply is not there, then output two will open. So this is your double acting solenoid bulb. Okay. Based on this, our requirement, we can choose whether I am going for a single acting solenoid bulb or double acting solenoid bulb. Now, if you are using a power cylinder, then definitely you better you go for a double acting solenoid bulb, else you can go for two single acting solenoid bulb. So if I am connecting it in this manner, so I am using a double acting solenoid bulb. So if there is supply, then suppose this port will be open and air will be going through this. This will push this piston to move up to this, and the lever will be going out. Now, when there is no supply, if there is no supply, then what will happen? This port will be closed, this port will be open. There will be a spring which will push the ball or the plunger inside, and this port will open so that air will be coming from this part, and there will be air pressure so that the piston is again on its original position. So your damper will be closed, and there will be two reed switch which are connected to your PLC to give you the feedback. Okay. So for a power cylinder, we need two DI signal, two digital input, you can see over here, and one digital output. Okay. So if you are going to connect a power cylinder, you need three channels, two digital input and one digital output adjust. Okay. So if it is clear, then we have discussed about. Yeah, so we have understood your power cylinder. Now
It's when, sir, one is at the same time one is releasing the power and another is pushing the power. And at the same time, another is releasing and another output is pushing, like this step.
means regarding a double acting solenoid bulb, you are talking.
Yes, yeah.
Not pushing or so means suppose air is going inside from this port, and there will be internal channel. Okay, let me draw a bigger one. This is a port, and this is another port. This is your power supply. Now there will be some kind of plunger like this. So if this port, this plunger is coming to this side, then air will be passing through this port. If this plunger is going to this side, then air will be coming to this side. Okay. So these are internally connected solid design, and they depend on the position of the spool. This is called your spool or plunger or some kind of ball, and this is pull or push through your solenoid coil, the supply of the solenoid. And if there are supply, it will generate a magnetic field. This will pull this plunger to this side so that this port will become open. If there is no supply, the magnetic field will be deactivated, and what will happen? There will be some spring that spring will push it and the spool will come here, so that air supply towards this will be closed and this path will open. Okay.
Sir, sorry, you just told me that we need 2 DI and 1 DO. Okay.
Yes.
Right. Presently, the concept behind 1 DO is I'm fine with it. That like for like if we can give supply, if we are putting it on, the 24 volt will be passing through it. If we'll keep it off, the 24 volt won't pass it. It will either on or off. But the 2 DI wala the concept is which is like I'm taking it for granted that right now we need 2 DI because I'm about to learn it, the concept behind this DIDO connections. So if you don't mind, you can explain me here itself or else I'll learn it.
2 DI means what? You need 2 DI because you need two feedback
Different
channel.
feedback on, yeah, two
Yes.
different feedback channel.
Whether it is on or it is off. Okay. So if this switch is acting, suppose this switch is acting, sorry, this will be on and this will be off. Or you can say not on off, you can say this is open and this is your closed signal. So if it is open, means your cylinder is here, then only it is open. And if you are pushing it, if it is here, then it is the cylinder is closed. So this switch will give you the feedback whether your power cylinder is open or closed. So one for open, one for closed. You need 2 digital input signal. Okay.
Okay, sir.
Okay. Next. So these two things, solenoid valve and power cylinder, they are mostly used if I am going to control any one of device. Suppose in general we use power cylinder for controlling the dampers of industrial fans. Now regarding your control valve. Control valve is something which is our analog device, is not it? Now to control a control valve, I need regulating supply. I need regulated supply means it will be varying from your 0% to 100%. Now for 0% to 100%, my PLC is giving me 4 to 20 milliampere supply. And I have to convert this 4 to 20 milliampere into
3 to 15 psi.
3 to 15 psi pneumatic signal. So I can use what I will be using? Which converter I will be using here?
Electro-pneumatic
What is the name of this?
positioner.
No. Positioner is different thing. This is not positioner. It is your I2P.
Sorry. I2P.
It is called your I2P converter. This is a converter. It is not positioner. Okay.
Yeah. This is only called as pneumatic, electro to pneumatic converter.
Yes. Current to pneumatic converter. Okay. So I have to use a I2P converter. I2P means current to pneumatic converter. Now to convert this current signal into pneumatic, what I have to do? I have to give a supply, ER supply here. And this supply pressure will be your 1.5 kg per centimeter square. And this 1.5 kg per centimeter square will be converted into your 3 to 15, or we can say your 0.2 to 1 kg per centimeter square.
So it is what it say. It is mandatory to keep 1.5 because we use what it say regulators for this. So we keep it near about different depending upon the types of manufacture. Like if it's a mascot, we keep something different. If it's a MIL, we keep it different. If it's depend upon the size of the wall also. So we change the air supply.
If you are using I to P converter, then in general I to P is the supply of I to P is always 1.5 kg per centimeter square. Okay, and the output is standard. It is 3 to 15%. It is something standard that are available in the market. So you have to go with this, and then depending on the valve, size of the valve, because this 0.2 to 1 kg is such a low signal that is hardly able to control the big control valve, is not it? So to control this control valve, we need some different PR pressure, likewise your say 3.5 kg per centimeter square, or say 4.5 kg per centimeter square PR pressure unit. Now I am having only 0.2 to 1 kg per centimeter square. So how to increase this pressure? Then you are using a positioner. Here you are using a positioner. Here you are using a positioner, which will, what it will do, it will amplify your signal. It will, number one, it will amplify this 0.2 to 1 kg signal. So this 0.2 to 1 kg signal will be acting as your control signal. This is acting as your control signal for this positioner. And once again, you have to give a supply air pressure to this positioner, say based on the requirement maximum pressure you want. So suppose 4.5 kg per centimeter square air pressure is coming in, and by this 0.2 to 1 kg per centimeter square pressure, I will be controlling some internal ball or something which will opening some port or partially or fully. Now this ball will be moving based on how much pressure is coming here. This will allow for from 0 to say 4.5 kg per centimeter square air pressure to be coming here. And this can be connected with your control. So my positioner is nothing but an amplifier plus your PID controller, pneumatic PID controller. Okay, we use two types of PID. One is your pneumatic PID, which is in the field with the instrument. You are using some bellows and there will be 2 or 3 bellows, and there will be crank and shaft and all. And you, by those adjustment of these things, we can set this PID. Okay, and another PID you can use inside the PLC, where you set all your process variable and all the set points like your P time, I time, P constant, and I time or D time. Then that will be using to calculate the electrical signal that is coming out 4 to 20 milliampere. And this PID is in the field, which is your pneumatic PID, and this is allowing a smooth movement of your control valve. Okay, so any questions on control valve? Flapper nozzle arrangement. Yes, Vivek, this is nothing but your flapper nozzle assembly is there inside this your I2P. Okay.
सर थोड़ा PID का थोड़ा एक्सप्लेन कर दीजिएगा.
So flapper nozzle assembly is inside this your I2P converter. We use likewise there will be a nozzle. There will be this will be my flapper. This will be my flapper, and there will be some orifice. So when air supply will be coming here, and if this flapper is close to this nozzle, then very less amount of air will be coming out of this nozzle. So all the air will be coming back and through this part, and this will be my output. This part is connected to your position. So ultimately, this is your amplifier, and then it is connected to this. So what is the difference between control system, PID control, and this PID? Sumant, I am not getting you. Control system PID and this PID. It is all same. This is also a PID, no? Proportional, integral, and derivative control. Just this is pneumatically controlled, and inside the PLC we use electronic PID.
So, is there any proper method or what it's a calculations so that like many times it happens when our what it's a our control walls start hunting. We need to go. It is working from 4 to 20. If we'll direct apply the source and we'll apply 4 milliampere, it comes on the 0%. If we apply to what it's a 8, then it comes to 25. So on till 75. 4 to 20, from 0 to 100%. But when it is on manual. When we take it to on the auto system, it starts hunting. So for many times we have to go and using trial and error method, we have to do PID tuning. So is there any method or a written calculation or a few parameters observation so that we can directly control PID, do PID tuning directly without any trial and error method? Because if we change PI, we need to give some time near about 5 to 10 minutes to observe the changes. Then we have to change I, then we have to change D. So is it something?
Yeah, definitely there are some calculations, but the calculations will give you more complex things. Okay, so PID setting is definitely based on your trial and error method. Suppose this is a control valve, is not it? This is my PID control valve. Now you can see here, this is the primary PID we are using, then another secondary PID is using, and then after the secondary PID, the output is going to my I2P converter. Now, how to set this PID? This is called PB band, process band. This is called I time. This is called D time. Okay. So PB band, it is the value of PB band will be suppose you can select it higher range, suppose 400, 500, 700, 800, up to 1000. Now, what this exactly do? If you are using if you know the PID control, then you know that the proportional constant Kp is directly proportional, means the error Kp into error will be the feedback. What that's called? Correction. Sorry, not feedback. Correction. It will be your Kp into the error signal. suppose I want to control this drum level at 40%. I want that this drum level should be at 40% in auto mode. Now, the drum level is exactly it happened in my earlier plant in Century Plywood. The drum level was supposed to be at 40%, but it was varying from your say around 35% to almost 48% or so. It just go very slowly. It goes high up to 45 or 40, 48%, and then come back to your 35%. So it took me approximately 1 or 2 days to sort this out this problem, and it was completely an observation, clear observation, and it was completely means hit and trial. So trial and error means what? You cannot go arbitrarily and doing so. So you have to observe that what kind of problem you are facing over here. Because the moment you are increasing the process band, it will be multiplying the error signal. So if I want, okay, it is 40% and I want to maintain this steady level when everything is steady. Once it is 40%, your set point is 40% and your level is 40%, then error is 0. Error equal to 0. Now, whatever your KP, that is not coming into the picture because KP into 0 will be 0. So correction will be 0. So whatever the position you are having right now, it will be maintained. But in case there are any differences come. So suppose the level is now 42%. What is your set point? It is say 40%. So there is a 2% plus error. Now, if your KP is say right now here it is your 640, so it will be multiplied by this much error percentage, and then it will calculate it, and then it is giving the signal. So ultimately, you will be finding that this once it is deviated from the set point, then it is never coming to the steady state level again. For that purpose, you have to set your I time or D time, which will giving you a smooth curve to minimize the error, to maintain coming to 0. Otherwise, it will be fluctuating in between a band. This band you can minimize by increasing the process band, but it will not always steady. It will go say 2% or 4% error in the higher side and once again in the lower side. So to do this, you have to use either I or D or both I and D. It will depend on whether your control valve is hunting or your control valve is responding very slow or responding very fast. Suppose you have given 50% and the control valve is going just a shoot from 0% to 50%. Or suppose you are giving 50% command and it is taking much longer time to go to 50%. So based on your observation, you have to go and play with this PID and you have to set that, okay, this is the best setting that is giving the satisfactory. And you have to note it down every time. Once it is set, you note it down, you give the operators to observe that, okay, what is the response of this control valve, giving feedback after 1 day, you are collecting the feedback, okay, this is the variations. You can go through the curves and then once again you can change your methods. So this is purely trial and error. Okay.
Yes, sir.
Sir, if you are means if you are मतलब ये सेट पॉइंट अगर हम लोग रखते हैं सर उसमें अगर सिस्टम में तो उसमें हम लोग अगर 4 सेट पॉइंट रखते हैं, एक होता है हाई हाई फिर लो फिर लो ऐसे करके रखते हैं, तो उसमें हम लोगों को ऐसा ये पीआईडी में क्या कुछ एडजस्टमेंट वगैरह करना पड़ता है सर क्या?
अब जो बोल रहे हो हाई हाई, दिस इज योर ट्रिप सेट पॉइंट. High, it is your alarm, high level. Low is your low level alarm, and low is your low level trip. Okay, high and low are trip signal, and these two are your alarm. So this is completely different thing. What is the use of these in your play? These 4 set points you are using for alarming and your tripping of the equipment.
तो इसका कोई रिलेशन है क्या सर पीआईडी से ऐसा?
नहीं, इसका कोई रिलेशन नहीं है पीआईडी से. ये तो इक्विपमेंट को ट्रीट कराएगा या फिर उसका कंडीशन के ऊपर बेस करके तुमको अलार्म देगा. इसका पीआईडी से क्या लगा?
ओके सर.
Now, in case of our say, in case of your power plant or boiler, in case of your boiler, the drum level is one of the most critical part, and to maintain this drum level, we use 3 element. We use 3 element control. Do you know 3 element control? Means, suppose this is your boiler. Let me close it. Suppose this is my drum level. This is my drum. I have to maintain this drum level. Now see, there are 2 things. Number 1, water is coming in from your boiler feed pump, and number 2 is your steam is going out. Water is in and steam is out. You have to maintain this level at 40%. Okay. Now, how to make the logic that how to, on what basis we will be writing the logic so that this 40% will be maintained. Now, there are 2 or 3 things. Number 1 is your drum level. You can make a logic that okay, if drum level is this much, set point is of drum level is 40%, and you can use this 40% drum level to control everything. But will it give you a good control? Definitely not, because suppose your water in is rate is your say 70%. And steam out is your 50%. Then you are giving 20% extra water every time. So your level will go high. And if you are looking at only drum level, then it is now 40%. And your water is coming in. And after some time, when it will be recognized that okay, drum level is going high, and you are giving command to your control valve, okay, the control valve should go low, and control valve is closing, by that time your level will go high. So you have to decide then what. So now you can go for a 3 element control. Means you have to calculate, you have to match this steam out, water in, and the drum level. This is called 3 element. 1 is your drum level, number 2 is your steam out, and number 3 is water in. And you have to match all the 3, you have to take all the 3 input. What is my water input, what is my steam output, and what is my drum level. When you are matching these 3, then you will be getting that particular control. Now, if you want to see the logic, I'll show you. This there what software I have given you about. You will be getting this 3-element control over there. I have just shown you. Now suppose I want to find out this. Okay, something that is creating problem. Yes. Now you tell me how can I find this 3-element drum level control in my logic? I do not know where, in which module it is also. How can I find it? Now there are so many modules and there are so many logics. So how can I find the particular drum level control from this? Can you give me some idea what to do? Any idea? I want to find out this drum level, means drum level control. My drum level is not maintaining. I want to find out the logic behind this. How to do? What to do? Give me some idea.
Maybe using address the address which is assigned.
Which address and how to find this address?
If I'll go to the panel room, open the control panel, I'll see that in which address it is connected.
No,
Then
wait. This is the SCADA page. This is the SCADA page. This is the drum level. Okay. So this drum level is not maintaining. I want to check the logic from where this all the calculations, the PID calculations and all. I want to check how to go to that particular module. How to find that particular module.
I'll go to the alarm section or the interlocks, because by these parameters my compressor will work or not, that will be defined. So I'll go with the interlock so that it will show me just an uh, uh, my thought of process, that I'll go and check the interlocks, so that by using in that I'll get this drum level logic or something.
But if you go for interlock for your drum level, there will be no interlock for your drum level control. No? Interlocks किसमें होता है? Interlock is for your equipments, whether if you want to trip it or something. Okay. So
सर पर यहाँ पे आपके कंप्रेसर ओके के लिए आप ये सारे पैरामीटर्स देखते हो, तो ये सारे पैरामीटर्स को आपने इंटरलॉक तो किया ही होगा ना, कि अगर इनमें से कुछ भी ओके है या नहीं है, उस वजह से कंप्रेसर पे इफेक्ट पड़ता है. अगर सपोज करो ड्रम लेवल लो है तो कंप्रेसर नहीं होगा, ट्रिप हो जाएगा, तो उसको ऑब्वियसली मैंने इंटरलॉक किया होगा ना. जस्ट माय
मैं बोल रहा हूँ यहाँ पे जो ड्रम लेवल है, ड्रम लेवल होना चाहिए था कितना 40%, ठीक है. ड्रम लेवल होना चाहिए था 40%. It is showing 51%. I want to check this, that why it is so, what goes wrong. Okay, so I have to go to my logic page where all the calculations have been done, the PID calculations and all. Now how to trace the path? How to trace the path from SCADA to your logic? Okay, that was my question. Saeed Ali, Suman, anybody can give me some clue? I have already covered this part. See, you want this particular parameter, which is not working, is not it? So you have to find the tag of this particular parameter. So to find this tag, what I have to do? I have to go to the on-build. I have to check this particular parameter tag. So it is LIC101 underscore 01. Now can you tell me in which module it is? It is a module 1. Is that it? So I am going to configure page and I am trying to find the LIC 101 or so. So LIC 101, it is digital input, digital output, analog input, analog output. Where I will be finding it? It will be definitely this analog input because it is showing your drum level. If it is drum level, then it will be analog input. So you can see here, this is my LIC 101. So here I have connected my transmitter. Means module 1, card number 1, analog input, channel number 1. Okay. Now I can see we are using this here. Okay. So this is the PID that I was talking about. This is another PID. This is another PID. See how many PIDs they have used to calculate this particular drum level. Now, which one exactly maintaining the drum level? The drum level is controlled via through this FCB. So I have to find out that, okay, which is the output for this FCB. So if you go here, you can see this is the output. FCB 101 underscore 01. Is it going to my analog output? Yes. This particular signal is going in my field to the I2P converter. This particular signal is going to the I2P converter. From which channel? From channel number 1, and it is module number 1, so it will be your channel number 1 of your analog output card. Now you can go and check the what kind of calculations have been made here. This is a PID controller, so you can simply, you are using this P band, the I time, the D time, and rest of everything will be calculated by this PID block. Okay, so we have to change this P time, I time, and D time. And this will be a PC auto manual, means either if it is auto, then this signal will be input 1 will be going to my output. If it is manual in manual mode, then input 2 will be fetched to my output. Okay, so either input 1 or input 2. There are two inputs. This is one block for your PC auto manual, and this auto manual switch means if this is one, the enable has been made one. Once the block is enabled, then input 1 will be fetched to my output. So it is already forced to 1. So your input 1 will be fetching to your output terminal. So your FCB will be receiving always this particular output from this PID. Now this PID is having the process variable LIC101 underscore 2 underscore 01. See, this is the process variable. Now you can see here LIC101 underscore 2 underscore 01. This tag has been generated. This tag has been generated 3 times. 1, 2, 3. 3 times this particular single tag has been generated. Now, as per our thumb rule, that one tag or one output can be generated only once in our logic. Then how they are using, they are generating 3 times within the same logic. What is the exact logic behind that? Then we can see here they are using some analog switch. Okay. Now this analog switch, if I study it, then I am finding here LIC101 underscore 01. This is something LIC102 underscore 01. This is another tag. Okay. Then what exactly they are doing? First of all, you should understand what is this LIC101 underscore 01. This is nothing but your drum level left hand side. So it is definitely the tag for a transmitter, which is giving you the feedback that this is the drum level in the left hand side. This is what this is your right hand side. So there is a drum, there will be two transmitter, one is in the left hand side, another one is in the right hand side, and we are taking both the feedback, right hand side level, left hand side level. Then what is this? This is your average LIC101 underscore 01. Okay. So, okay, this average LIC101 underscore 01 has been generated here. And if I see this, there is a average block. And I am using the LIC101 signal here. See, the same signal I am using here. Means the transmitter which is connected in the left hand side, the signal from this transmitter I am collecting, the signal from the right hand side I am collecting, and then I have given number of inputs too. That means I am taking the average of these two. Now the average signal is used here, and this average will be coming to my output, and this average will be coming to your PID input as your process variable. There is another part where I can see that there is a compare block, and this compare block you can understand if the set level, there is a set level and there is something, some constant, network constant I am getting. So if it is these two, input 1 and input 2 are equal, then this will be coming out as my output. If input 1 and input 2 of this compare block is same, then this will be coming out. If this is 2, then this will be coming out. Now what this 1, 2, 3, these are the constants, and you can see that okay, there is a tag select label underscore 0. From where this tag is coming? Okay, check it over here. Select boiler drum level. Now this is coming from your SCADA base. You can go here and you can see, check here. Okay, this is the select level. From the activities. PID feedwater control. No? PID feedwater makeup water. PID feedwater control. So, if you go to this, you can see here the same tab. Select level underscore 01. So go here. This is the select level underscore 01. That means where if I select here 1, 2, or 3, I can select either 1 or 2 or 3. Anyone, either 1 or 2 or 3. If I select it here 2, this 2 will be going where? It will be come here. 2. Now this compare block will match. Whether it is 1, no. Yes, it is 2, then this signal will be triggered. If I select here 1, If I select here 1, then what will happen? Then this signal will be triggered. That means at any instant, only one output will be coming up. It is not that since I have used this or the same tag 3 times I have generated, all the 3 cannot come together. That will depend on my selection, on the operator's selection. If operator is selecting here 1, then the signal from your block 1 will be coming. If operator is selecting 2, then this will be active. If operator is selecting 3, then this will be active. So any one signal will be coming as your LIC 101_2_0. Now if this signal, suppose I have selected here 3, that means I am using the average level for my calculations. Since 3 is selected, that means this 2 will be inactive. This one and this one will be inactive. And this particular analog switch will be active. OE, you can see here, enable signal. So if this is enabled, then which one will be coming to the output? The average level will be coming in the output. If this is active, then your ground level right hand side value will be coming to the output. And you will be using this particular signal for all your calculations. Here also, here also. Now, what you have to do next, you have to use this PID settings. The PB band, you can see here PB band or P band. So P band 6, the low limit is 0 and high limit is 1000. Means you have to select value in between 0 to 1000. Means some counts 0 to 1000. In between 0 to 1000, you have to select some P value. Then your I time, it will be your 0 to 10. I time will be 0 to 10. You have to select it in between 0 to 10. And your D time will be also in between your 0 to 10. You can select them. Once it is selected, once it is done, the PID will calculate internally and it will give you a signal here. This signal is coming to your PC auto manual, and this signal will be fetched based on this auto manual selection bar. Based on this auto manual selection bar. Now, from where this selection bar is? Selection is this one. 1 and 3 element mode selection. Now I have to go once again to my SCADA page. What is 1 and 2 means? See here, there is a switch, single element, 3 element. If it is single element or it is 3 element, this is your 1 or 3, single or 3 element mode selection. Okay. So based on this here you can see it is written as 1. If it is single element has been selected, then this PID is giving the command to your FCD. If it is 3 element, then 3 element is selected, then it will be something different calculation. Okay, this is for your 3 element and this is for your single element. If it is 1, then your this output will be fetched. If you select 1 here, Means if you select single element, single element, then the output of this PID will be coming to your FCD. And if you select three element here, means it is not one. You select here three element, then this three will be coming here, and since the enable bar is one and it is mismatching, that means input 2 will be fetched to my output. And from where I am getting this input to, it is from this PID. And all the calculations have been done here. So this is my secondary PID, and this is my primary PID. You can see here, one is your primary PID, another one is your secondary PID. So anything changes you made here, this PBI or D, this will be coming here, PBI or D. Then this will be fetching to some scale. This will be making this data value that is coming out of this PID in between this particular scale. Then there are something which is adding some values. Then you are manipulating it with the set points, and then ultimately final PID value is coming. And this is it. So see how many things are there. If you go through this simple control of this particular control bar. Okay, what is there? I have to give it some set point, and this control bar will work. It is not that much easy. You have to write some PID control. You have to go through all the logics, and then you can say, okay, why this drum level is not working. Okay. Now, each and every point where our focus should be, first of all, if your control valve is not working, then check whether your I2P is giving right output or your PLC is giving the right input to the I2P. First of all, I have to check the channel, that okay, whether if I am giving say 0% command, then whether what amount of current is coming out. Remember one thing, if it is your analog signal, always check 4 to 20 milliampere. Don't go for the voltage if it is not voltage signal. Okay, there are some analog signals which are using your 0 to 10 volt, but normally it is your 4 to 20 milliampere. So if you know that okay, it is 4 to 20 milliampere, and if it is your I2P, you first check on which channel it has been connected. Go to that particular channel. You give some command from your SCADA page. Suppose you give first 0 command, and for that I can make this manual, and then I will be giving some 0 command. Now what will happen? You must receive 4 milliampere signal on that particular channel. Is not it? If it is 100, then you must get 20 milliampere on that particular channel. Now, if it is 20, coming as 4 to 20, if it is working, you can check by giving say 50% command. If it is 50, then your 12 milliampere should come. Because if it is your 4 to 20, then 4, 8, 12, 16, 20. So this is my 50%. So if you are giving 50% command over here, you must get 12 milliampere. If it is coming like that, that means your channel is working. The I2P input, you check at the I2P input. If your I2P input is receiving 4 to 20 milliampere, then check for the I2P output, whether it is giving your 0.221 kg or not. If it is also giving accordingly that 0.221 kg, then you can check your positioner. Why the positioner is not working or what? If your positioner is responding accordingly, you can try adjusting the PID setting of this positioner, or you can try adjusting PID from this controller. So adjusting a positioner is really a difficult task, and it cannot be taught online. Until and unless you are in field and if you are not opening it and adjusting it by your hand, you will not understand this part. But adjusting this electronic PID, it is very simple. You just give some set point over here. Suppose 640 is not working, try for 750 or 740. Make it large or give it 850 and check what is the response of your controller. If it is working, then okay, well and good. If it is not working and the fluctuation is more, if it is going more, then try to close the band. Okay, then you give 750 and check how much variation. If the variation is coming shorter, then make it 700 and check. Okay, it is coming. And after certain point, you will see that okay, there is no more scope. And then you go for your I setting or D setting. Likewise, if the response is not that far much good, or if it is hunting, then you try to set your I time or D time and then check. Okay, what is this is the way how we do. Okay. So somehow what you got it from this one, how to set your control valve. If not, then you are all are having the software go through this FCV setting today. Check from where these values are coming, how this has been set here in this logic, and try to understand what is what. Okay. So anything regarding control valve?
Sir, positioner and PID control में कोई रिलेशन है क्या सर कि वो जस्ट डिफरेंट है ये पोजिशनर अलग?
नहीं, पोजिशनर और पीआईडी कंट्रोल एक ही है कि दो टाइप का पीआईडी कंट्रोल, जैसे मैंने आपको बोला अभी दो टाइप का पीआईडी कंट्रोल है। एक तो इलेक्ट्रॉनिक पीआईडी कंट्रोल जो हम कर रहे हैं पीएलसी में, जो कैलकुलेशन है जिसके थ्रू हम लोग कंट्रोल सिग्नल निकाल रहे हैं। दूसरा है जब आपका न्यूमेटिक सिग्नल आपका पोजिशनर में आ रहा है थ्रू योर दिस वन I2P कन्वर्टर, उसके बाद आप न्यूमेटिक पीआईडी सेट कर रहे हो पोजिशनर के अंदर। सो पोजिशनर दो चीज के लिए काम कर रहा है, एक तो हो गया एम्पलीफायर, एज एम्पलीफायर इट इज वर्किंग, और दूसरा है पीआईडी कंट्रोलर के हिसाब से काम कर रहा है। ठीक है, तो आपको दोनों जगह पे काम करना पड़ेगा। अगर आपका कंट्रोल वर्क सही ढंग से काम नहीं कर रहा है तो फिर आपको पोजिशनर को भी छेड़ना पड़ेगा, वहां पे देखना पड़ेगा कि भाई मेरा पोजिशनर सही से कमांड दे पा रहा है कि नहीं, and how to analyze this whether it is working or not. You can have some say milliampere source with you, okay, and simply go and connect this milliampere source to the I2P input. Give 4 milliampere command, then the milliampere source will fetch 4 milliampere. Check the position of the valve. If it is at 0, then okay. If it is not at 0, adjust the control valve. Then come and give 20 milliampere signal. The bulb must open to the 100%. If it is not so, then adjust the control valve. And then you can understand if the variation is not working. That means you need not to work on your PLC side. You have to work on what? You have to work on your positioner.
Field side, sir.
Yes, you have to adjust the positioner.
Yeah.
Remember, if you are going to adjust the positioner, be very much careful, because once the setting is disturbed, it is really hard to make it set right. Okay, so it needs much more practice, and I'll be saying that instantaneous ideas. As an instrumentation engineer, your hand are just like what? जो कहते हैं ना सुनार होता है ना, जो ज्वेलरी बनाता है, उसके हाथों की तरह होता है, एकदम सॉफ्ट होना चाहिए. You should not go for a large variation at a time. मतलब मैंने अपने लिए इतना सारा किया है, ऐसा होता है ना कि कभी कभी बोर्ड लग जाता है, क्या हो रहा है, एकदम माइन्यूट चेंज, योर वन माइन्यूट चेंज विल मेक ए बिग डिफरेंस. And once it is disturbed, it is really hard to bring to its original setting. Okay, so be very careful whenever you are going to do always small changes in settings and check the response, and it takes time to be perfect definitely through your settings. But the way is same. How to check, I have made you clear that whether you have to change your settings in your electronic PID, or you have to change check your position. Okay, there are some electro-pneumatic positioners terms where you will not find I2P. The I2P will be integrated inside the positioner itself. Okay, so there will be a positioner with your I2P. That is called your electro-pneumatic position. So there are different variations. Anyways,
Sir, we can call that that PID control from the SCADA side and positional control through the field side. We can say like that, or PID.
you can say electronic PID, and you can say your pneumatic PID. Pneumatic PID is your positioner, electronic PID is your PLC.
Okay.
Okay, so आज के लिए इतना है ना, छोड़ते हैं अभी. It's 9:50. Good night everybody.
Good night, sir.